Hello friends, after this session you will understand a little bit more about permutation combinations through two examples which I am going to show you now. The question is, in how many ways can three students be put in three different classrooms equally? In how many ways can three students be put in three different classrooms equally? And a variation of this question is, in how many ways can three students be divided in three groups equally? Look at the questions. If you look at the two questions in black and pink, the difference is in first one, it is three different classrooms. In the second one, it's just three groups. The groups are not different among themselves. That is what you must understand. Now, for the first question, we just do simply, since there are three boys, three classrooms, so one boy goes into one classroom. So from the three, I select any one in 3C1 ways. From the three students, I select any one in 3C1 ways, put him in the first room. Out of remaining two, I select any one in 2C1 ways, put him in the second classroom, and the third guy gets selected for the third classroom, and there are 6 ways of doing it. This is for if the classrooms are different, the boys are different, classrooms are also different. Now, if I just have to divide 3 boys into 3 different equal groups, so I can do it in only one way. Whether I divide A, B and C like this, or whether I put B here, A here and C here, it does not change. They are all 3 different. There is no classroom. There is no differentiation as the groups are concerned. So the answer here will be 6 by factorial 3 because there are 3 classrooms. Remember, this 3 here implies 3 classrooms. 3 different classrooms were there in the earlier sum. So this factorial 3 was there in the numerator. Now whatever answer we got here, it will be divided by 3 factorial because the difference of classrooms is not there, and so the answer is 1. Please start from the beginning if this concept is not clear to you, because the next sum will be a variation of this sum itself. So you can start from the beginning, understand this concept well, and then carry on. The next question is, instead of 3 students, the change is there are 6 students. Okay? Just to show you how the whole thing works. There are 6 students now. Question in black is same. They have to be divided in 3 different classrooms equally. And question in pink is same. They have to be divided in 3 groups equally. And the groups are not different among themselves. Which means the groups are not numbered. The groups are not named or anything like that. It's just a division in groups. So like before, for 6 students to be divided into 3 classrooms. Each class will have 2 guys. So I pick 2 out of 6 students. Since it is a selection, we use combination. 6C2 ways of filling the first classroom. Out of remaining 4, I select any 2, put them in the second classroom. Balance 2 students go in the third classroom. And you solve it. Factorial 6 by factorial 4 into factorial 2 into factorial 4 by factorial 2 into factorial 2 and so on and so forth, get the answer as 90. So there are 90 ways in which 6 students can be divided in 3 different classrooms equally. Now as before, what happens if these 6 students have to be just divided into 3 different groups? So just like before, what answer you got here as 90 divided by factorial 3 because the groups are not different among themselves. The groups are not numbered. The groups are not named. Earlier the classrooms were different. That means the class 1, 2, 3 or 1A, 1B, 1C. Here the groups are not named. They are not numbered. So the number of ways of distributing them equally in 3 groups will be factorial 3 times less. So 90 by factorial 3. That is 15 ways. Cheers. For more clarity, let us name the guys as A, B, C, D, E, F. So, since we are dividing into groups of 2, we can have a group where A and B are together, A and C are together, or AD, AE, AF. This can be done in 5 ways. A can be grouped with any of the remaining 5 people in 5 ways. Now, B has already been grouped with A, so we can group B with C, D, E or F in 4 ways. Similarly, C has already been grouped with A, C has already been grouped with B, so C can be grouped with D, E or F in 3 ways. Likewise, D has 2 more options to be grouped with E and F, E has 1 more option to be grouped with F. Now if you add this up, you will find that there are 15 ways of doing it, which collaborates the answer we earlier had. I hope the concept is clear. Thanks.